Hi, my name is Dianhui. I'm with Chevron. I'm a data scientist in Chevron, and the three of us made a contribution to this project, and the other two persons, Peter and Dennis, they came out with the idea, and I was the person who wrote the code and make the idea happen. So I have to say this is not a production project. We do it as a hands-on experience on handling very large big data set. The project is meant to get the first experience, and then we will probably push it into a production project. I will not go through all of the items that are listed here. So I will talk a little bit about the problems we are trying to solve, and then the HBase table design we did for our particular project, and I will briefly mention the performance we have out of the project. So here's the problem. In Chevron, we know we have servers that are compromised every day. So quite often people want to ask, if I give you an IP address, can you search all the accesses that are associated with that server, and we want to search that data within maybe the past 3 months or even a year, and it is quite trivial if the data set is not that big. If it is comfortably small, we can do it in a very efficient way, very easy way. But if you're talking about data at a petabyte level, it's going to be a big challenge. So our purpose was to search the data against the petabyte level in a very fast way, or even more ambitious, we want to be real time. So that's why we came up with choosing the Hadoop HBase as our infrastructure for a project. We're not trying to develop a infrastructure for database by ourselves, and we just want to use the open source softwares for our purpose. This is a very ugly picture of the data flow for our project. So basically, we have all the historical security logs in the file system. We put into the Hadoop file system, and then use the MapReduce tasks to sync the data into HBase such that we can do real-time search. So this is a little bit about how we design the tables and how we use HBase to do real-time search. We have a primary table. What we call primary table is the logs table. It basically nothing but the entries itself. We put each entry as a value in the row, and then the row key is the MD5 checksum, and then. So that way, with that table, we can do relatively fast query on all the data in the table by writing our own MapReduce tasks, or even use Hive that can high-level tools to make it happen. But in this case, we want to be real time. So that's why we come out with the secondary index table at the programming level, and in that table is basically we design a row K that has the IP address in the first 4 bytes, and then followed by the reverse time stamp. So this, which is pretty much a standard approach in the HBase tables. And the thing that we do, what different from our project is that we add the MD checksum on the fly when we pass each of the log entries. So that way, because the way HBase works, it will go to, because in HBase tables, all the row keys are indexed. So if you have a set of row keys that has the same prefix, you will go to the specific region and fetch it out, and then that's how real-time happens. This is a picture of the conceptually how these two tables, the relationship of the two tables look like. You have the, I guess this is the pointer. Yeah, you have the primary table, you have the key and the value, and then when we sync the data into the table, we generate the secondary index table. By this, you have the key, and then we add all the MD5 checksums on the fly. And so right now we put, so that has, my time is gone. Okay, I'm sorry about that.